Welcome back everyone to another video, and in this one we'll be taking a look at running an actual AMD Radeon GPU on the Jetson Nano. So what I want to show is sort of the middle ground in PCIe implementation on ARM devices. Now we've seen the really crappy one where barely enough bar is used, and those are the lower end ARM SoCs, whether those are for Chromebooks, low end phones, or like a Raspberry Pi. They start with the issue of bar, but they have so much more that's not implemented, whether it's AER or proper MMIO or anything else like that. It's a mess for the most part. And on the other side of the spectrum, you have something like the Honeycomb or any large ARM servers that have really good PCIe implementation, and now even in a lot of cases PCIe 4 implementation, and they work flawlessly with things like GPUs, and GPUs barely stress those PCIe implementations. So Jetson Nano is kind of like the middle ground, but sort of leaning towards the cheaper implementation. But it still manages to run a GPU in a sort of way. So before I start to talk about actually running the GPU, let's just take a look at the actual setup in more detail and what you're seeing on my desk. So let's open up the SOM to reveal how I have actually connected the external PCIe slot to the baseboard. So for those of you who don't know, all Jetson Nano boards do come with an M.2 slot that is capable of PCIe X1 lane. So we'll just take a quick look at that. Right, so we have the SOM popped off, and as you can see, here's your M.2 slot. Now this is a key E slot. It's not the M.2 NGFF or the NVMe slot. Those are different. Those are differently keyed. Those are key M slots, and then key A, B slots are usually for without PCIe. But anyways, this is key E slot, and that has one lane of PCIe, and it's usually used for PCIe based network or Bluetooth cards, or even cellular modems, but stuff that's done over PCIe rather than just USB. I found it very difficult to obtain a direct M.2 E key to X16 or even X1 slot. These aren't easily available where I live. So that's why I had to go from PCIe M.2 E key to mini PCIe, and then from mini PCIe to a full X16 slot. And even I'm surprised how all the signal integrity is being maintained through the loop, but it seems to be working fine at the moment. I have tested some non GPU stuff as well, your usual SATA networking, like a LAN card, and they seem to work fine. So yeah, moving on, let's go ahead and close the SOM. Now I don't remember if I've done a video on the Jetson Nano, but I really wanted to take apart the SOM and show it to you guys. So if I haven't done it already, I will do it sometime later. But yeah, let's put this back together and get started with the real thing. Alright, so I have broken out a few more wires. Those are usually just the reset, recovery mode, and power. And then I have UART connected to my main system. For the first boot, we are going to just boot with HDMI on the Jetson just to see what that looks like. And again, I am running Fedora 34. All of the work that needs to be done, to like all of the code that's there is in the upstream Linux kernel. Or the Nvidia specific Linux distribution doesn't really support any of it, especially like an AMD GPU or any external GPU, their Linux side of things is a bit weird. So I just ended up going with the upstream and more um, main Linux distro, um, rather than using Nvidia's specific Ubuntu-based image. Just because I was more comfortable and I knew that the code base is correct and the code base will work. It's just about the hardware at this point. As you can see, this is my console. That's my serial console connected to the Jetson Nano, and then I also have the HDMI connected to the capture card. So right now we are in EFI, which we do need to edit. So quickly, I'll just edit the EFI to actually show some stuff on the main on the serial console rather than straight up going to the frame buffer console, because we do kind of need the serial console for editing, for in case stuff locks up on the graphical side, we can recover it from the serial console. But yeah, moving on. So as you can see, it shows the Nvidia logo on the frame buffer. This logo is usually generated by pre-Linux boot stuff, even pre-U-boot. So that's just a frame buffer placeholder. And then when it actually starts to boot, the DRM will take over and show us everything. That's nice, including a GNOME. So just waiting for the entire Linux system to boot up and for GNOME to start. So here you can see the GNOME login screen, and we'll just give this a quick go. And slowly we have GNOME 40 loading up in the background, and there it is. That's GNOME 40 with the onboard graphics driver. So all the glitches you're seeing are actually present, and as I said, it's a reverse engineer thing with the mainline Linux, especially for the GPU sides on Nvidia hardware. So it's not really perfect by any means, but it's something that works and something you don't have to press I agree to the license button on. Right, so we have the terminal open and just run a quick GL Mark II to see how things are going. Um, do remember this is a 4K display output, since the capture card reports itself as a 4K display. Um, and what all you are seeing is actually being scaled up. So, yeah, those glitches are normal. But look at the GL Mark II demo. It's limited to 30 frames per second because it's running on a 30 hertz refresh rate, like the entire frame buffer, because it's on 4K, and that's probably not on the Jetson side. That's more on the capture card side. But apart from that, it reports the GL device correctly as Tegra, since we're using the onboard graphics, and with the GL version as 4.3. So let's move to the more interesting part, power it all off, and then add the new GPU. Right, we are back at the desk, and I have powered off the Jetson Nano, and this is the GPU that I'm going to use. It's a Sapphire R7 250. It's a 1 gig GDDR5 unit. I've used it in a lot of videos. This was the GPU that I used with the UEFI ARC64 GOP driver, but again, that stuff's not related to this video because the Jetson Nano does not have a UEFI plus ACPI implementation for its bootloader, and the bootloader cannot run UEFI drivers. It's a generic U-boot which runs EFI binaries, but it doesn't mean that it will run EFI driver in any sort of meaningful way. So yeah, this is a separately this is a completely different use case. In this case, like Linux handles the frame buffer post startup. So again, we are just putting the graphic card in, connecting the HDMI cable to the GPU. The GPU is powered by a separate power supply. It's one of those Pico power supplies. I don't know if I've shown this on the channel before, but probably in some build video. These are like tiny 150-watt supplies that run off of 12 volt and provide the 5-volt switching capability. And yeah, so I'm just using it, and I'm using a power supply tester to turn the power supply on, so that provides the power to the GPU itself. And then I have powered on the power supply for the Jetson Nano. Those two things are on different power supplies. And then the Jetson Nano starts to boot. Here we have a bit more work to do. We have to add some very interesting kernel command line flags to make this all work, and I'll explain them as I write them. So the first one is simple, just get everything on serial working, serial console working. The next one's a bit more interesting. So as I said, the PCI implementation is not perfect, so there is a need to disable AER, or advanced error correction, or advanced error reporting. Disable MSI, disable ASPM, and yeah, those are required. Otherwise, it floods the entire D message with errors, and it will not work. We disable Plymouth from starting, so we just want GNOME to start rather than have Plymouth disturb something, or I haven't had luck with Plymouth working properly. And of course, blacklist the no-view driver so that the output doesn't go to the Jetson Nano, and disable mod set on no view. I don't know if that's necessary since we've already blacklisted it, but just for a different use case. And then we added log level 7 so that we get a bit more verbose output. So DRM needs to load Radeon needs to provide all the frame buffer, graphics memory, and all of that stuff, and then GNOME starts and draws something on the output. As you can see, we already have DRM and Radeon related outputs. We'll look at them in a bit more detail later on. But first, here it is. The as soon as DRM got a frame buffer, it has started to display it on the output. And again, this is a 4K display, and it's capturing everything in 4K, so it looks extremely tiny and more ant-like. So for me, while editing this video, it actually looks more like Morse code than anything else. But let's just wait for GNOME to load up. It will take a few more seconds. And there we go, we have the GNOME login screen show up, not scaled at all, but yeah, once we log in it will be scaled. Anything 4K should be by default scaled to 200%, but no one does that, which even makes me madder. So yeah, quickly logging it in, and we will have the gnome 40 desktop in front of us in a few seconds. And there it is, gnome 40 running on a Radeon, on an AMD Radeon GPU on the Jetson Nano. So what's really going on though? Is it really working on the Radeon, or is there some misery going behind? For that, we'll open up a terminal quickly. Suspiciously enough, it's very slow to open up and to display it, and doesn't feel that smooth. So let's make it a bit bigger to give us a bit more space to work with, and then run GL Mark II. Which, apart from the weird errors, it kind of works. But let's take a closer look. It says it's running on LLVM pipe. Instead, it should have said something along the lines of Radeon or AMD or even ATI would be fine. But when you see LLVM pipe, it means it's actually running in software mode, i.e., it's not rendering stuff on the GPU itself, but there's still a video output. Um, Again, a top just shows us what we were thinking, and then yes, GL Mark II is using 200% of the CPU, which is 2 cores, and it's or like distributed between the 4 cores. um yeah, so it's definitely not running on the GPU itself. So let's see what's going on. D message output will show us properly, and I'll first output DRM, and then I'll output Radeon by grepping those words. So DRM shows us that it has detected the card. All the VRAM space has been correctly initialized. All the ports are initialized, and what else? Frame buffer is initialized. We've got an FB0, so that will be present as at /dev/FB0. Everything else looks fine here. Let's take a look at more of the Radeon side of story. I think that's where the issue lies. Right, so I'm actually moving back to the serial console since it's a bit more responsive. And then we look at the dmessage errors there. And then we'll go for the Radeon specific one. So I've grabbed Radeon from dmessage, and VRAM seems fine, GTD seems fine, and as we come down the list, the only error is down below where it says ring 0 test failed. And this is one error that I've read in Jeff's GitHub issue about running the Radeon drivers on CM4. So those guys were running on the same issue, and maybe we, you know, that issue seems to be stopping the GPU from coming up. Now, I've not looked in detail into this issue, so I'll probably do now. But yeah, it just disables GPU acceleration, and that sort of makes sense why we were seeing what we were seeing in terms of GL Mark II running on software rasterization. What we need to understand here that what we know of as a GPU is not like one thing. It's divided mainly into two parts. The multimedia or video processing side of things that outputs stuff over HDMI, and the shader units. that does the actual graphical or calculations and 3D calculations and all of that stuff. Linux's DRM driver, which the Radeon driver or the AMD GPU driver is a part of, is mainly responsible for the video output and allocating all the memory buffers and stuff like that. And this is a very higher level explanation. I'm not going into the detail. Um, but the the shader unit driver or the rasterization driver is handled by Mesa. Mesa is a user space driver. It uses all the pipelines and character devices and other ways of accessing the GPU that the DRM driver initializes and interacts directly with the shader units to get your 3D stuff running. And that part is what's not working. This GPU's shader driver fails at that ring zero. The shader unit initialization fails at that when that ring zero test fails. So as you can see, even with Radeon top, it just shows everything at 0%. So it's just being used to give a display outlet for GNOME or the frame buffer, and because that's working, and everything else is being software rendered. So is or does a Radeon GPU work on the Jetson Nano? The answer is both yes and no. Depends upon your definition of working. So that was kind of it for this video. Before we go, I do have to share one more thing. I did try a few more GPUs, and it it wasn't too good. So the current one that I've shown you, that the one that's running, is the R7 250. I had another one called the HD 3000 series something, 3450 or something. It's a 1 gig DDR3 GPU. It does not even have the AMD branding anywhere. It just uses ATI Radeon. It just says advanced micro devices on the silk screen on the back of the PCB, but that's just it. So it's a really old GPU, and this crashed like hell. I'm just assuming that's because that that code path has never been run on ARM, and there are some serious x86isms in the code base. So every time it's just being tested with x86, whereas modern or even slightly modern Radeon drivers have been tested with PowerPC, ARM, and x86, so they work fairly well. The other one I tested was a RX 560, and this one was again crashing with some interrupt issue on the driver when it loads the driver and tries to load the frame buffer. This works fine and this is actually the one I'm using on the Honeycomb right now as my main workstation. So main ARM workstation. So this already works on ARM fairly well. I think it didn't work here because of the crappy PCIe implementation, which is not as crappy as all the most of the crappy implementations, but it's still pretty crappy. So yeah, it didn't work either. So I guess my R7 250 was kind of the perfect fit. However, I hope you all enjoyed the video, and hope to see you all in the next one. Bye.